Good evening, guys. Welcome to another Revise for a Prize session. How's everyone doing today? Sorry, I'm slightly late just to come over. Sorry about that. Hi, TKD. Hi, Philip. Good to see you. Debashri, hello. Sorry, yeah. Hi, Yakusa. Yakuasi. Sorry, Yakuasi. Epic Sports, hello. Yeah, hope you're all doing well. And that's everybody. Dennis as well. Good to see you back. How are we all this Sunday evening? We are how many weeks from? I guess we're not far from Easter break now. I guess for people, three weeks, maybe something like that. 3-4 weeks. The year's flown, guys. The year's absolutely flown. We're in March already. I mean, I blink. I thought it was like 3 weeks ago. It was like start of the new year, but here we are in March. Yeah, time's flying, which means we're closer to exams. Yeah, so we're getting there. So would like to get closer to reaching the end of your syllabuses. Hopefully we are definitely getting there on FRL classes for those of you that are with us. So definitely get close to finishing that so that you can get into real revision in terms of practicing questions and past papers and stuff. But yeah, cool. Okay, I can see a few people have joined. For those of you that are new here, I'll explain it as I always do. Here we're doing a session where I'm going to go through some content that's going to be covered in the quiz that we're doing today. Today's quiz is going to be on electromagnetism and magnetism. Okay, so something later on in the syllabus, a topic that people tend to find more difficult. So we're using it obviously as a session for people to learn ultimately, right? We got this quiz here, we revised for a prize. The aim is to then do a quiz on those topics, and the top two win a prize. The top winner gets a £25 Amazon gift voucher, and second place gets a £5 Amazon gift voucher. So join in, guys. I can see 16, 17 of you in the channel so far. So please message in the chat. Remember, to win the prize, you also need to engage with me when I'm going through the content. Yeah, I want to see some learning going on. That's the aim, like I said, of today. Yeah, whether you win or lose a prize, ultimately it's about learning. Okay, so please do join, take part, ask questions. Yeah, that's what this session is for. Let me know if there's anything you don't know in this topic that I'm going over that you want me to, explain in a bit more detail. But fine, you haven't learned the topic that we're going through. Don't worry, that's the point of today. I'm going to be covering this information. So pay attention in the class, ask me any questions, and you'll be ready for the quiz anyway. And it's a topic learned then. Yeah, so you're going ahead of school even. So double bubble there. So I see a few of you have joined. You can see the Kahoot code at the top. I'm going to write it down here as well on this slide. So when I go back to it, people that are joining can see it. So it's 4918708. So that's 4918708. Keep jumping in. I see 7 of you there. Some of you have mentioned who you are. Let me drop the shout to Debashri or Fab Lemming, TKD or Power Heron. Power Heron? Yeah, I've not seen that name before. Nice. Raghav, you just revised this today. Nice. Okay, I'm expecting to see you high up there. Let me know maybe who you are, or if you're like Philip, you don't like to tell us who you are. You tell us at the end. That's fine. So as I said, Epic Sports, the topic is magnetism. Cool. I'm going to go to our website. So as for those of you that have been here before, the website we've made is flashrevisionlab.com, yeah, which is here. So you can see on topic by topic as per the syllabus. Okay, so I'm going to say, as I've mentioned today, the bits I'm going through: magnetism, magnetic fields, and then electromagnetism, and a bit of motor effects. So those are the 4 topics I'm covering today. And with each section, click on it, you can see we have a section for notes. So really, we've broken down the site. You log in with an account for free, and you get access to all of these notes. Yeah, so all of this is going to be there. You'll see exactly what I'm showing you right now. All the notes here. You can see the tab here. Like I said, we cover everything in the spec. The way you know that is you can click on this tab, and it shows you exactly an excerpt from the spec itself, showing you what points are needed to know, and that is covered. You can cross-check that with the notes, and you'll see it's exactly what you need to know. Okay. And for those of you that want a bit more from this, we have an FRL Pro subscription. So basically, for less than basically a coffee per month, you get access to all the questions here. Yeah, so there are some questions available on the sign up when you sign up initially with no fee, but you don't get access to. So get FRL Pro, you can just get full access to everything on the website. That includes all these questions, along with mark schemes to review the answers and make sure you're happy with answering the question correctly. And as well as access to this new feature, flashcards. Okay, so for example, ask this question to you guys. Drop it in the chat now if you know the answer. What happens to an induced magnet when the magnetic field is removed? So an induced magnet is like a material that becomes magnetized when you bring a magnet into it. Okay. So when I remove the magnet, does anyone know what happens to the induced magnet? No charge, and that's not quite right, Shadow, because this isn't about charge, right? It's about magnetism. So Philip has said it, demagnetized. Yes, it's not charge. It's not that it loses charge, it loses magnetism. Demagnetized. Yeah, it loses magnetism or demagnetized. People are getting it now. Nice. So if I flip the card, you'll see it loses its magnetism. Yeah, so that or being demagnetized is the correct answer. So those of you that got it right, well done. You put that in the no section, you click that and it will send it to the right. For those of you that don't or didn't get it right and want to keep it for testing yourself later, you click still learning, shifts it to the left. Yeah, and then you have a view of all the flashcards that you've covered and it will bring back the ones that you said, oh, you're still learning. Okay. So correct, guys. I can see some of you are getting it. Very nice. So Sammy, good to see you there. Good answer. Sahana, not correct, not a magnet, but I'd say just loses its magnetism or demagnetized are the better terms. We want to use those scientific terms. Okay. Cool. So that's just a brief run through of the website. So I just want to start going through the content now. So with magnetism, okay. So people mention charge. Charge is to do with positive and negative. Yeah. That's not what we're looking at today. That's the more electricity, static electricity, and charge. Today we're looking at magnetism. So that's a non-contact force, like the electrostatic one, but it's a non-contact force between poles of a magnet. Okay. So where with charge we talk about positive and negative, here with magnetism we're talking about north and south pole. Okay. So the two poles, they interact with each other differently. So if we had opposite poles, say north and south, they would attract. Okay. Same with south and north. If I had them the other way here, they would attract. Okay. If you had like poles, so the same ones, so north and north or south and south, when you bring them near to each other, if you've done this at school, you probably would have experienced it. You push the magnets or don't push heavily, but bring and they start to wobble and kind of move off like this because they're pushing each other away. They're repelling each other. You can feel that force in your hands slightly as you bring the magnets together. They move away from each other. That is repulsion. Yeah. With the north and south, when you bring them together, you bring them to a certain point and then they stick together. They attract. Yeah. So you feel that difference. So Harley, you're talking about charge. That is not what we're talking about here. We're talking about okay. So positive and positive, negative and negative. That's all charge related. That is not this topic. So don't get confused with that. It's an important one there. Okay. We're talking about magnetism and poles. So like poles repel, opposite poles attract. Then we also need to know the difference between, as we saw the question in the cheat sheet, permanent and induced magnets. Okay. A permanent magnet is something that always has its magnetism. An induced magnet is one that becomes magnetized in the presence of another field. Okay, so if I brought a bar magnet to a magnetic material, it becomes magnetized. It then becomes an induced magnet. And as we saw in the question, when you take the magnet away, it then loses its magnetism. It's no longer magnetized. That's an induced magnet. A permanent magnet, as we've said here, produces its own magnetic field. So it always stays magnetized no matter what. It has that magnetic field all the time. Okay. With that being said, in terms of induced magnets and magnetism or things that can become magnetized are called magnetic materials, and they're specifically these four types that we talk about at GCSE: iron, steel, nickel, and cobalt. Okay, so sometimes people confuse that all metals are magnetic. That's not always the case. There are these specific materials that are more magnetic than others. Okay, there's iron, steel, nickel, and cobalt. Okay, so those are four important materials. Comes up in questions in exams quite a few times, so it's good to remember that. So, like we said earlier about induced magnets, see this iron bar, which is a magnetic material, as it stands alone, it is not magnetized. Yeah, it's a standard iron bar. But then when I bring this magnet towards it, this permanent magnet, it then becomes magnetized and it becomes attracted to it. So if the north pole is brought near to it, the nearer side to the north pole of the magnet will become a south pole in the iron bar. Okay. And then it causes it to attract. I then pull it away and we get back to the situation at the top and the iron bar is no longer magnetized. Okay, and that's simply what the notes here is telling you at the bottom. Okay, so this is our first section. If I've completed it, I'm happier that I've covered it. I can mark as complete, and you can see I'll click it. It like buffers here, and eventually it's ticking green. And as you can see here at the top now, I've got a bar. One is a bar and one as a tick. So tick to acknowledge I've covered the topic. You can see what ones that I haven't don't have the tick next to it. There are only 2 topics in this section. So I'm 50% done. It marks that with the bar. So if you leave the website, you've done your revision for the evening or the day, you go away, you come back another day and do it, you can see exactly where you left off. Yeah, so we're trying to give you a solid revision tool now as we get into exam season, for something where you can kind of use that to make sure you're prepared and track your progress in terms of revision. Okay, so personally, I think it's really useful. I wish I had this when I was doing my revision. Something to kind of, give me a track of where I am without having to write things everywhere all the time. Yeah, so ready set of notes we've given you, questions for you to practice, all in one central location. Okay, so that's what we get from the website. Like I said, FRL Pro is our level above that, about a cost of a coffee per month, and you get access to everything on the website. We also have, some of the guys in the chat can tell you, we have FRL classes. Okay, every week we run separate classes which now delve into these in more detail. We give you a workbook every session with gaps in it, so you can follow us along the classes and fill them in as we go along, leaving you with a full set of notes at the end. There are also questions at the end of each workbook specifically on what we've covered in that lesson, so you can practice exam style questions on that topic. You then try those, and there's also walkthrough videos for you to look at to see how you've done. And if you don't understand it, hopefully help you explain how to answer the questions correctly. So all of that we get for each science. So that's biology, physics, and chemistry each week. So chemistry on Fridays, biology and physics on Sundays. So the guys that are here from our class, we just did it about an hour ago now. Yeah, about an hour and a bit ago. We just had their class. And yeah, every week we do it. So that's 12 classes a month. And that's £22 a month. Yeah. So that is 12 class a month, £22, about even less than £2 per class. Yeah. So I don't know anyone that's doing a class for that little. Yeah. So especially at this time, we're trying to give you as much help as we can. So if you want to join us, a few of us are in here. Really kind words. Thank you, Philip. Much appreciated. Yeah, Philip, Sammy as well. Thank you very much. You guys are, really appreciate you having you with us. And the good thing about it is, obviously, we just have a community of people, right? People all that want to smash their exams, all trying to help each other. Even Sammy was telling us earlier in our class today, jumped from a 2 to an 8. Yeah, 2 from his mocks to now an 8 in his exam, the most recent exam. So it shows you, with the right revision and the right mentality, obviously has to come from yourself as well. You want to do well, and obviously you guys are here because you want to do well. Yeah, that's the aim. I know you all are here because you want to do well in your exam. So that's what we have, a group of like-minded people, community that want to help each other. So yeah, come and join us. We'd love to have you. How do you revise for required practicals? It's funny you said that. Even with today's class I did with the guys earlier, we literally did a required practical day. Yeah, I specifically spent the class going through just the required practicals, specifically on the topic before this on waves. Yeah, and that we just try and walk through exactly what you need to get, because the hardest thing with required practicals is 6 markers, right? You always see that 6 mark, you see that big gap in the paper. I know it always used to scare the living daylights out of me. I used to see it and go, oh no, I've got to write a lot here. Yeah, every time I see it. It used to be daunting, but what we're trying to do is break that down so you have a way of systematically remembering it, so it's easier for you when it comes to the exam and doesn't scare you to see that in your exam. You can smash it out by remembering those points. For example, as Philip said, we try and make memory tricks as well for them. So tends to require practical. Exactly in your face is an example of one that we have. We always try and come up with more memory tricks where we can. Anything to help you try and remember things a bit more easily. So we cover one topic. I'm just going to go back to the Kahoot, see how many people got 4. I saw 7 before we started. A lot of people have dropped off. I don't know if okay. Can you guys hear me okay? A few of you have dropped off that you may do come back. We're going to start in about I'll say in another 5 to 10 minutes. We just got these couple of other topics to cover. So hopefully you guys will be coming back. Magnificent Armadillo, I know someone said that there was them, so hopefully you're coming back in. I'll give it a few more minutes. We'll go to the next bit, magnetic fields. Okay, so what is a magnetic field? So a magnetic field is an area or a space in which that magnetic force or magnetic effect can be experienced. Okay, and where do we get that? We get that from either a permanent magnet, a magnetic material like the ones we mentioned, iron, steel, nickel, cobalt, or a current carrying wire. Okay, and this is the new bit that you mentioned in this part of the topic. It's a little laggy. Hopefully it picks up a bit. Sorry about that. Last time I had this last week, and then as we got to the quiz it picked up, so I'm hoping it's okay. I did see people drop off the live, but people are coming back now, so I'm hoping maybe you can hear me okay still. It might be the screen's a little bit blurry, but bear with me. Hopefully it will come back. I don't want to mess around with things too much. It might set things off a bit more, but hopefully it should be okay. So magnetic field lines, yeah, we see them. They are invisible. We see them on a piece of paper when we see them in questions. Yeah, so you can see there where I'm talking about a strong field and a weak field. The lines are like so, but physically you won't see them. When you hold a bar magnet up, you're not seeing magnetic field lines around it in reality. Yeah, we're just showing them on a diagram from what they've discovered about magnetic fields and how magnets work. We've come up with how magnetic field lines will look like. Okay, so the key thing here as well is knowing the directions of them. Okay, so they always go from North Pole to South Pole. So they're traveling away from the North Pole and towards the South Pole of a magnet. Okay, so when you think of fields, they go from north to south, right? So that's one thing to know. And then here I'm talking about the strengths of fields. So the field lines, if they're closer together and there are many more of them, that means it's a stronger magnetic field. There's more effect that you're going to feel. If it's weaker, then the field lines are more stretched, more further apart. And here we go. There we go. An example of a bar magnet. You can see here that with the magnet, if I drew it on here, so I'll take it the same as it's in there. So north on the left, south on the right. The arrows are all coming out of North Pole. Like we said, the lines travel from north to south. So they're going from north all the way around to south. So I'll say they travel out this way, all the way back around and pointing in towards south. And you'll see that on both sides. And then you see the lines in the middle they've drawn going away from north, but in towards south. Okay. And that's what you see all the time on a bar magnet, north to south. Okay. And like we said, in terms of the magnet, when the lines are closer together, the field is stronger. If you look at this on a bar magnet, the bits where the lines start to really bunch up, you can see here, the lines are closer on the left and on the right. So at the poles of the magnet, you can see these lines are way closer together. Yeah. If I drew them on the other parts of the magnet, you'll see them something like this. So you can see the distance between these two lines and these two lines are a lot more. Yeah, so really we see the strongest part of the effect at the poles of the magnets, and the field is strongest at the ends. Cool. And then there is an experiment here, not practical as such, but there is an experiment that they talk through. It does come up in exams. I'm just going to briefly go over it. How to observe the magnetic field around a magnet. Okay, so I'm going to talk through the diagram here. I'll keep this up here for now. And we talk through each step. So we need a compass, okay, because a compass is going to tell us which way is pointing north. Okay, we take the bar magnet, we put it on our piece of paper, I lay it down, I then put a dot at the first point where in the corner of the bar magnet. So I'm picking the corner of north here. Yeah, I could have picked this corner, I could have picked the right hand corner or in the south pole as well. But you need to pick one point on the magnet, make a start from there, and then put your compass on there to point the direction, and the direction that it's pointing in, you draw the second dot. Yes, you can see here, I've started the compass from the first dot. The red arrow is pointing up to here. So I draw my second dot at the tip of that arrow. Okay. So now I have two lines, but now I keep repeating that now. So I go to the next point, put my compass there, plot the direction of the next arrow. So you can see here that now starts to curve up. So we're starting to get a curve. We keep doing that, repeating it and repeating it until we go around. So we repeat it and join the dots with a curve. And you can see that is our path of our magnetic field. Okay. So those are the steps. And then you do this several times from different points of the magnet. So you can see you've done it at the bottom left, bottom right, top and bottom left, top and bottom right, middle of each, and then we follow it all the way around. Yeah, so that is what we do repeatedly. That forms the magnetic field around the object. I got confused on which is true north and which is true south on Earth. Is north of the Earth and true south and vice versa. Okay, so the difference is north, geographical north, and magnetic north are not the same. Okay, they're not the same. So that's why you just don't attribute them to the same thing. So North Pole on the Earth is not North Pole on a magnet. They're actually the opposite. Okay, so just treat them differently. Magnetic north and geographical north are not the same. That's the thing to remember. Yeah, that's what I would say. So don't refer to true north as such in this. We're only referring to magnetic north, which is the north that you'll see on a compass, for example. Yeah, that uses magnetism. So we refer to magnetic north. So I would say I get it. It can get confusing to mix the two up. So I would say just avoid using the term true north. In this topic, we're only talking about magnetism. So magnetic north and magnetic south. That's all you want to refer to. No problem. Good question, actually. People do tend to try to bring that up and then it gets complicated. So no, good question. Cool. So that's the first two sections. I said a couple more topics to go through, so I'm going to quickly whiz through those, but let's see how many people we have. Not many, only 5. No, people are in with a great chance of winning a prize today if that's the case. You've only got 5 people. Come on, guys. There's 15 people of you in the chat. So, yeah, drop in there, drop me your names in there. And there's sort of a few people that gave me their names but aren't in there anymore. I don't know if it's a signal thing again. Hopefully, people's signal is okay. But okay, 6 of you there so far. It's a good chance for anyone if they want to join the chat to join in and get we want to increase our demographic. Exactly the point for it. Cool. Okay, I'll carry on in the meantime. Obviously the code is here 4918708. So jump on. Cool. Now the next one is electromagnetism. Okay, so electromagnetism, basically electric, and magnetism is a combination of both. Yeah, so it's when there's a current in a wire, we say that there's a magnetic field acting around it. Okay, so you can see here, we're saying that there's a current flowing in this orange wire. The field lines around it are what we call concentric circles. Concentric circles mean circles that are continue to enlarge around it. Yeah, like think of like dropping a pebble in water directly down in water, the ripples that it makes, that's concentric circles, where the circles go out and out. So that's what concentric circles are. You've beat me to it. Obviously, you can see at the bottom here, Philip, the right hand grip rule tells us the direction of this now. Okay. So by right hand grip rule, I mean you take your right hand. Okay. Don't, I'm doing it, but obviously, if you don't understand it, follow me as I'm doing it because I'm mirrored to you. Okay. So I don't want you to get too confused. And I've got a thumb up there. But grip your hand like you're doing a thumbs up to somebody. The thumb indicates the direction of the current in a straight wire. Okay, remember this is for a straight wire. Okay, so the thumb up indicates the direction of the current, and the way your fingers grip. So if you look in your hand, so I'll show you from this end, but look at it the way that you're using it. This grip in your fingers. Yeah, so go from your knuckle to the tip of your finger. That shows you the direction of the magnetic field. Okay, so if I'm holding my thumb up, I look at my direction of my finger, that is anti-clockwise. So you can see here in this diagram, the fingers, see this direction of the fingers? They're going in an anti-clockwise direction. So for a straight wire, the thumb shows the current, the curvature or the grip of your fingers shows the direction of the magnetic field. Okay, so that's what we see here. Current upwards, my thumb up, and the field lines are going anti-clockwise. And here's where I add the arrow there, anti-clockwise. Okay, but then obviously, depending on the diagram, you can be in different directions. So if the current was flowing downwards, my thumb will be downwards. And then I look at the grip of my hands, they are going in a clockwise direction. Okay, when I look at it and I follow from knuckle to the tip of my finger, that is in a clockwise direction. So always depending on the side that you draw it, but you use the right hand grip rule for a straight wire. That changes when you come to a solenoid. A solenoid is essentially when you take a wire and you coil it up. You turn it into a coil. Almost looks like a spring in the end, because you've turned it into a coil. So you start with a straight wire, you turn it up. It's like wrapping, when you wrap a controller away. For those of you that play computer games, well, nowadays you have wireless controllers. I don't know what example I'm giving here, but back in the day, you have a controller that had a wire on it. If you want to tidy it up, you wrap the cable around. Yeah, like wrapping that cable, putting it in a loop. That's a solenoid. Yeah, so you do that just obviously without the controller inside it. So wrapping a wire into a coil, the coil is called a solenoid, essentially. Okay, and the difference here is that when you have a wire as a solenoid now, the right-hand grip rule flips around. What do I mean by that? I mean, let's take this coil. It's horizontal, so I'm going to hold my right-hand grip rule, but horizontally. Okay, I'll face you guys horizontally. The thumb now shows the magnetic field. And the grip of my fingers shows the direction of the current, because the current is obviously going through the coil. So it's going to be turning through the coils now, isn't it? And the field goes straight through the coil. So you can see here in this diagram, the field goes straight through the coil. Yeah. So that is the difference. With a straight wire, the current is the thumb and the grip is your magnetic field. For a solenoid, the magnetic field is the thumb and your grip is the current. Yeah, it swaps around. So that's one thing to remember. There's a key difference between those two. Okay. Now, you're a bit late. You can still win the prize. Take part with us, Royal Akbari. No problem. I still got a few more minutes. The code is here, 4918708. So join that. But obviously, just answer some questions with me here as I'm going through it, or ask me anything if you don't know it. So, like Debashri has asked, what are the ways we can increase the strength of magnetic fields? So, in this case, obviously the aim here is not to look at the strength of the magnetic field yet. But there are questions that come up with this. Okay, we're not doing it yet. But if you wanted to increase the strength of the magnet, you generally just use a larger magnet or something that is stronger. Yeah, or maybe a stronger material. You could even flow more current through the wire. The more current that's going through the wire, the stronger the field's going to be. Okay. Having more coils in the wire when it's a solenoid, that will also increase the magnetic field. Yeah. So those are different things you can do. But it tends to get asked more around the topic of electromagnets and when you get an electromagnet, which I haven't come on to yet. So I'll show that in a second. And you'll see it in the notes as well. But yeah, exactly. Right? I have more turns in the coil or more current in the coil. That will be a way to increase the magnetic field strength around the coil. Okay, so remember, I've just mentioned the right-hand grip rule. One way around for a straight wire, one way around for solenoid. So that's important. Now, the direction of your thumb is pointing to the north. Okay, so like we said, it's traveling from north to south, but this direction of your thumb points towards north in the right-hand grip rule. Okay, that's also important to remember. So you can see here, north is going to be on this side. So the line is traveling from north around to south. Yeah, where do we see that? We see that up here. So this indicates to us, this is north. It goes around and travels to south. And remember, field lines travel from north to south pole. Okay, so that's for a solenoid. Okay, and it's showing you the grip is the current, the thumb is the magnetic field. And you can see here, the line is from south. It's going away from north and into south. Yeah, so again, the rule still stays the same there. Here we go, an electromagnet. Okay, so an electromagnet, it becomes an electromagnet when you put that magnetic material within the solenoid. Okay, so in this case, the magnetic material, the best one to use is iron. Okay, now for anyone that has done this already, can anyone tell me why is it that we use iron? I mentioned steel, I mentioned cobalt, I mentioned nickel as the other materials. Why have I mentioned iron, and why is iron the best one? Dennis has mentioned it's soft. Yeah, so people have said it's magnetic. It's not 100% right. It's a combination of both of you. It's magnetically soft. Okay, it's a magnetically soft material. That's why it's used, because steel is also magnetic. Yeah, cobalt is also magnetic. Nickel is also magnetic. So the reason I'm saying iron is because it's what we call magnetically soft. I'm going to put that here. Okay, magnetically soft. So what I mean by that, and I've mentioned it in the notes there, we'll see it in a second. It means that it can become a magnet and then turn off being a magnet. So obviously it's magnetized and demagnetized very easily, like a flick of a light switch. Yeah, I can turn the current on, the iron becomes magnetized. I turn the current off in the solenoid, the iron is no longer magnetized. If you did it with steel, for example, I turn the switch off, there'll still be some residual magnetism in it. It will take a longer time for it to become demagnetized. Or sometimes it may just stay as a magnet once it's already got current in it. Okay. So but with iron, you have that control. It can be magnetized and demagnetized very easily. Okay. So magnetically soft means it can be, or not it can, it just say can be magnetized and demagnetized easily. Okay. What is a solenoid, Royal Akbari? You did miss it. Can someone mention in the chat? It's an early quiz. Yeah, the pre-quiz to the quiz. Can someone answer Royal Akbari's question? What is a solenoid? I've mentioned it already. Can someone remember or recall it or remember it already themselves? What is a solenoid? A coil of wire when it's wrapped up. Exactly. Yeah. So when you turn a straight wire into a coil, that's when it becomes a solenoid. So that's here. It's coiled up. Yeah. So that's what a solenoid is. Simple as that. It's a coil of wire. Okay. And then when it's exactly right, as I've just said, you now add an iron core into it, and you put the iron core into that coil of wire, you get an electromagnet. Very good. So here's an example of what we're saying. You have this electromagnet, but there's no current in the wire at the moment, so it's not magnetized. When we have a current in there, so I've added a battery to this, it's now got current in it. Current in the wire means the iron becomes magnetized. And how do we see that happen? It now attracts the paper clips. Yeah. Say if I then take the battery out, the current stops flowing. Now the iron becomes demagnetized, the paper clips drop, and we get back to this scenario. Yeah, and it does that immediately. That's why we use iron, because it does that thing immediately. If it was steel or maybe even nickel and cobalt, it wouldn't do it straight away. It's not as magnetically soft as iron. Okay, so that's why we use iron instead. Cool. So that is 3 out of 4. We got one more, and then I'm going to start the quiz. So literally just another 2 or 3 minutes. I'm going to cover for the last topic, and then we're going to get into the quiz. So let's see how many people we've got now. I'm expecting more people. Only 7. There's 15 of you in the chat, guys. Get in there. I want to see more of you. I want to see some competition here. 4918708. There he goes. 8 of us. Keep jumping in. So Dennis, you're saying, can I do an example of the right hand grip rule? I'll do that quickly. Okay, so I'm going to do it on this paper. So let's say, like I said, if the key thing here as well that I haven't mentioned is sometimes if you have it going into the page or out of the page, sometimes it comes up in an exam. Okay, so if you're going out of the page, so what I mean is you're looking at the piece of paper literally down in front of you, and we're saying the current is coming out of it literally into your face. Okay, so your thumb will be pointing towards you. Okay, how does that look on here? You assume it's like an arrow. So when an arrow is coming towards you, will only very late, but you'll see the tip of the arrow, and that would just be a dot. So we put a dot. This indicates current out of the page. Now, Dennis, what I'd say you do is, if you use the right hand grip rule, this is a straight wire I'm talking about. So the thumb means the direction of the current. And I've said current out of the page. So take your right hand grip rule and point your thumb literally towards your face, like I'm doing. So my thumb is pointing towards myself. And then I look at the grip of my fingers. My fingers from knuckle to tip are going in an anti-clockwise direction. So I draw circles, remember concentric circles. So equal circles around the wire there, and they're going in an anti-clockwise direction. So I draw arrows going anti-clockwise, like so. So that's for current out of the page. Okay. Then in the opposite scenario, you can imagine, obviously, if you do it with your hand as well, you'll see it with the right hand grip rule, current into the page. Now your thumb should be pointing away from you. Yeah, so I'm pointing it towards you, but my thumb is pointing away from me. Now with that, if you see it had an arrow, this time you're shooting the arrow is going away from you. The end of the arrow, you put it in the bow, it has like a cross on the end. So we show that on here as like a cross. So that's current going into the page. Okay, so that's what that is. Now, if you take your right hand grip rule, you take your thumb and point it away from you. Look again at the grip of your fingers. Now, if you look at your fingers, they are going from knuckle to tip, now going in a clockwise direction. So my concentric circles, I still have circles, but I do them in a clockwise direction indicated by these arrows. So that's the difference. Yeah, and you're using your thumb to show that direction. Okay. Are transformers on the quiz? No, I'm not covering that today. I've only got one more bit, which is the motor effect. I want to cover that, and then we're going to do the quiz. Okay. Dennis, hopefully that helped. Let me know if there's any other question you have on that. Hopefully that made sense. Is everything in the revision session only in the quiz? Yes, exactly. Yeah, TKD, that's the point of this. I want to teach you something, and then let's see what you've retained for what I'm covering in the quiz. Okay. So hopefully you've been paying attention to me, TKD, and you will get a good mark in this quiz. Okay. So one more bit I want to cover here. Why has one got more shells? It's not shells, it's like magnetic field lines. So I can draw another one. Just to make you happy, I'll draw another one. Yeah, so I can do another one. There's no particular reason. I was just lazy. I'm honest. Okay. You caught me out there, Sammy. But yeah, it doesn't matter. I would, in the exam, I would say I'd draw 3. 3 is a safe number at least. Yeah, if you had a question like this, don't draw less than that. Don't be lazy like me. Draw at least 3. Okay. So you're right. You've called me out correctly. 3 is the least number of field lines you want to draw on this kind of example. Okay. Same with the bar magnet example that we saw. You'd want to draw 3 or 4 lines at the minimum. No, it's not. It's not, Sammy. Sorry. No. But well spotted. It's good that you're paying attention, catching me out. That's what I like to see. Cool. So the last thing is motor effect. Okay. And what we're saying is with motor effect, a motor, what does it do? It moves, right? It rotates, for example, but it's creating motion. So the outcome of the motor effect is motion. But what does it come from? It comes from a current carrying wire entering a magnetic field. So when it goes into a magnetic field, there is a force that is exerted on the wire. Okay. So the reason it has to be current carrying wire is because remember earlier we said even with the right hand grip rule, the field forms around the wire when there is current in it. So you can see here with this straight wire, there's a magnetic field. You put it into this bar magnet, that's 2 magnetic fields, 2 different ones that are interacting with each other. We get our, for example, like our north to north, south to south interaction. So between 2 magnetic fields, you get an interaction and that creates a force. Okay. So it's when you can see here, the current carrying wire is placed in a magnetic field of a magnet. Both the fields interact and it creates a force. And that is what the motor effect is. The force that you produce from the interaction between a current carrying wire and a magnetic field. Okay. So that's essentially what the motor effect is. And this is where I think Debashri asked this earlier about here we talk about how do you increase the motor effect. So how do you increase the amount of force you create from the motor effect? Okay. And there's a few ways you can do it. One is the straight wire with current in it, add more current. The more current there is, the greater the field you're going to interaction you're going to get, then the greater the force you're going to get. The other thing is look at the bar magnet, use a stronger bar magnet that will have a stronger magnetic field, more interaction, more force. Okay. So those are the bits you want to say for that, for increasing the magnitude of the force. And to finish this off, there is an equation. Okay, it's been a while in physics. Usually I mention one every lesson. It has to be done every time I do a class. Here is another one. F equals Bill. Yeah, where B is the magnetic flux density or magnetic field strength measured in Tesla. Yeah, so like the car, it's measured in Tesla. So flux density is the strength of the magnetic field, what we otherwise call magnetic field strength. Okay, usually that's what we hear it as, but obviously they want to use a more scientific term. That is what magnetic flux density is, the strength of the magnetic field. Exactly, Raghav. The strength of the magnetic field. And it's measured in Tesla. I, we've seen before in electricity, is the current in amps. And L is the length of the wire. You multiply those three, you get the force. Okay. So you want to make sure when you do a question, you have everything in its standard units. So we'll briefly look at this question before we get into the quiz. So the last few people who haven't joined, please do join. Here we go. Magnetic flux density is of a magnetic field when a current of 600 milliamps flows through 80 centimeters of wire and experiences a force of 50 newtons. Okay, so here you want to break down what do we know. So current at 600 milliamps, not in its standard unit though. We want amps. Yeah, so milliamps to amps. I've written it here. You divide by 1,000. So 600 divided by 1,000, we've got 0.6 amps of current. The next number they mentioned, 80 centimeters of wire. Distance isn't usually centimeters, it's meters, isn't it? So here I've done another conversion, centimeters to meters, you divide by 100. So 80 divided by 100 is 0.8 meters. So you have 0.6 amps, 0.8 meters. That covers off I and L in the equation, okay? And then they've told us 50 newtons of force, which is F, and that's in its standard unit. We can leave that as it is. So we know force, we know current, we know the length. So if I put that here, F equals Bill, they want us to find the magnetic flux density, B. So I rearrange this equation so that this is on its own. So B equals F over I times L. Okay, so there, that's what we've done. We've rearranged the equation, force over current times length, using all our standard units. So 50 over the 0.6 for the current that we said, and the 0.8 meters for the length of the wire. We put that all together and we get the answer there, 104 point something, which rounds to 100 Tesla. Yeah, remember magnetic flux density, the strength of the magnetic field is measured in Tesla. And there we go, an example of the question. So bear that equation in mind. Small tip. Let's see who can remember it. Okay, and those are the topics I wanted to cover. Okay, we've covered the 4 topics. You can see here marked on the website now. You can see even the ones that I've done with you guys in previous last week's class. I did particles, model of matter. You can see they're ticked off, everything we covered. Yeah, so you can see I've come back to it later and it's keeping a track of everything that I've learned so far. So really good tool, guys. Have a look at it, flashrevisionlab.com. Free to sign up for all the notes, and you can see our other packages on there. Yeah, FRL Pro for all the questions and flashcards, and then FRL classes that we do where myself and Neen host the classes like lessons for you guys, all 3 sciences once a week for just £22 a month. All right, enough from me. We've reached the time. We're going to get into the quiz. We've got 9 people. I'm going to give it another 30 seconds. Another 30 seconds for people to join. 4918708. There's a real high chance of you guys winning. We've had as much as 22 people before. It's dropped off. If you know anyone, even if they want to take part, join in. Malika, I think I missed you there. Hello. Sorry, I missed you earlier. Hello. Hope you're doing well. And yeah, okay. I think 11. Okay, I'm going to give it just another 10 seconds. If everyone's ready, we're going to make a start. It's going to start with a poll, as we usually do, just to get you used to it. Remember, we have typing questions, we have pinning questions, we have quiz questions with multiple answers. So yeah, be ready, be right, and be quick, and you can get there. So let's see who's going to be our champion and our runner-up today. Good luck, everyone. I'm going to make a start. If you're just joining, don't worry, you can still jump in. It's going to be the poll. So good luck, everyone. Let's see. My first question is to you guys. If I can remember, what did I put? It was a poll on the Your plan after GCSEs. What do you plan to do after GCSEs? Are you going to sixth form? Are you going to college? Are you doing an apprenticeship, or are you doing something else? Are you going straight to work? Are you taking a break from school? I don't know. People may want to do different things, so just want to just to get an idea of where people are at. Um, yeah, I mean, when I was at school, didn't know much about apprenticeships. People didn't really mention it, but a couple of you are doing it. That's interesting. Would be nice to know, whoever you are, what you're going to do an apprenticeship in. It's a really good way to keep kind of doing learning, but also hands-on experience at the same time. Really, really good opportunity, that. So nice to hear people are doing that. Most people sixth form and college. I did expect that. Something else. Who's doing something else? Is that wishful thinking that I want to do something else, but I don't want to? Or are you actually doing something else? It'd be good to know. Who are those guys by any chance? You want to drop anything in the chat that answered on the bottom two there? Self-study A levels. Nice, nice. Fair enough. Gives you a bit more time, I guess, to sit the exams whenever you want. So yeah, fair enough. Yeah, fair enough to you. Cool. Okay. And the apprenticeship guys, yeah, nice. Okay, cool. Just a bit of an interesting one to start. Hopefully we're ready. First question is coming. Let's do this. Quiz question to start. What do like magnetic poles do? They attract, rotate, repel, cancel. Everyone's in pretty quickly there. Sixth form, but hopefully extracurriculars and physics, Philip. Nice, nice. That would be cool. Physics is tricky, but if you love it, there are people that really love it and are really good at it, and you might be one of those, Philip. So obviously, I've seen you in our classes. You know what you're talking about. So yeah, fair enough. Good start. One person made a mistake. Like poles. So like poles would mean north and north or south and south. They will repel each other. Okay. Opposite poles means north to south or south to north. They will attract, but like poles repel. Okay. How does that leave the leaderboard? So no thousands, but two 983s. Two people level. Quick Falcon and Wonder Liger. Both of you are on 983. Amazing Raven, Magnificent Armadillo, Power Heron are all just within 3 points of each other. So the top 10, the top 5 separated by just 10 points. Very, very close. Kind of what I was expecting, because it was a relatively easy question. But nice to see everyone's in with a shout. Yeah, so unfortunately for the one person that got it wrong, it's not over though. Remember, we've seen before, plenty of amazing things have happened. People have dropped off last minute. Don't lose hope. Let's get into question 2. Good luck, everyone. A quiz question again, but it's multi-select. Which of these materials are magnetic? So there's going to be more than one right answer in there. Which of these are magnetic? Cobalt, iron, copper, and nickel. Which ones are magnetic? So I did mention this a couple of times earlier in the session today. Who can remember what I said? I think there's just one other person to answer. We'll give it the 3 more seconds to run out. What have we got? So most people got it right. A couple of people mentioned copper. I don't know if they were there or maybe missed it. Guys, if you just joined, you can join the quiz. The quiz is on the code 4918708. I'll leave it there. You can still join for the fun of it. Obviously, it's a bit of learning as well. But nice. Okay, let's see how that leaves the leaderboard. Okay, remember the 4 materials are cobalt, iron, nickel, and steel. Copper is metallic, but not magnetic. Okay, not all metals are magnetic. So that's one thing to remember. So a bit of change there. Wonder Liger has dropped off. Don't know what happened there. But then the Quick Falcon is still taking a lead. It's about 100 points now. So there's our leader to start. But we've got Hero Dove that's climbed. Kind-Hearted Snail has joined the leaderboard. Glorious Sugar Glider has also joined. I think Debashri were there. Magnificent something, if I remember right. You've come off there. Did you get it wrong, or just slower than some people? Obviously, it was 3 answers, so that's why the scores have jumped significantly. Power Heron, I think that was someone else that mentioned there in the chat. So hopefully you guys are in with a chance. Yeah, everyone in the leaderboard is in with a chance at the moment. Let's keep going. Quiz question again. What direction do magnetic field lines travel in? So I did go through this a little bit through a few sections with coils and with magnets. So is it north to north, north to south, south to north, or south to south? Which one is it? You're not there, but you're. Yes, that's the mentality to have, Fab Lemming. Yeah, I'll keep an eye out for you. Hopefully, you come through the ranks. So, what is the answer we put in here? Most people got it right. One mistake. North to north. I didn't say north to north. North to north is just when 2 poles repel. Remember, like poles, they repel. But lines go away from north and towards south. So north pole to south pole. Okay. I showed it in the diagram for magnets and also in the case for the poles in a solenoid. Yeah. So I did mention it a couple of times. but unlucky for the one that didn't get it. But how does that leave the leaderboard? On no change yet, but the scores are pretty close. So Glorious Sugar Glider and Quick Falcon's still in the lead. Can anyone catch them? There's about 90 points there, and then about 50, 60 points second place, and then it's pretty much the same gap through 60 to 70 points each. But 8 participants have a streak of 3, so people have got everything right. Good to hear, good to know. Hopefully you picked that up from today. TDK, I haven't seen you in the chat. Hopefully you're getting these. Hopefully this session is helping you to remember the answers. If not, remember, if you get something wrong, you always make your learnings best from when you make a mistake. Yeah, that is always a way to remember something, because you always remember that you got it wrong that time. Yeah, I always find that lessons learned are always best when you got it wrong. But if you're getting it right, keep it up. Nice, you got it all right. Good to hear, TDK. Next question. True or false? Magnetic field lines are visible. True or false? Very quick answers there. I'm glad to see that. You're too slow. That's fine. I mean, ultimately, you're doing the right answer. Okay. If you're getting the right answers, you've learned something. That is the aim for today. That's what I said, right? But are magnetic field lines visible? True or false? And do you do space? We do, but remember that is also a triple science topic, not just combined science, right? I think that's only for triple science students. So we do it. We cover it in our classes. We do it in boot camps and things that we have going on later on this year, in the next month or so, as we get close to exams. Yes, if you use iron files, you can see them, but they are not. You still don't see the actual lines, right? The filings show you the direction of, show you the outline of the field. They don't show you the direction, do they? They just show you a field pattern. But you have to put filings there. Without the filings, you don't see the lines. So just around the magnet as it exists, there are field lines that you don't see. So it's false. Magnetic field lines are invisible. Okay. So there we go. Yes, Philip, you said, the paper 2 summary doesn't have space in it because it's a triple science topic. So I left it out of there, or we left it out of there. Sorry, Nina's left it out of there for now. So yeah, it is triple only. So not for everybody. Cool. Let's see how this has left the leaderboard. People have still got all 4 right. People have entered back into the leaderboard. And Devashri, is that you? Magnificent. No, you said Fab Lemming. You're not there yet. Magnificent Armadillo. That was someone in the chat, I believe. Who is that? Jumped onto the leaderboard. You have a chance. Power Heron TDK. Nice. You've entered back on the leaderboard. In with a shout. Definitely in with a shout. Raghav. That's it. Nice. You've entered as well. Good to see you guys there. It'll be interesting to see who Hero Dove and Glorious Sugar Glider and Quick Falcon are. Quick Falcon is still in the lead, but it's now reduced slightly from 90 to about 70 points. So yeah, Glorious Sugar Glider is catching. Who's going to be the winner? Cool. Next question. Pin the answer this time, okay? So you need to put the pin in the right place and press submit. Where is the magnetic field of a bar magnet the strongest? Drop your pin in the area that you like, and if you're happy with it, press submit, okay? It doesn't enter automatically by dropping the pin. You have to press submit. People have mostly got it. Let's see where that leaves everyone. Do people remember I mentioned it? I did mention it when I looked at the field lines on a bar magnet. Hopefully you guys were listening. Let's see who was and who wasn't. 4 more seconds, 2, 1, and let's have a look. Couple of people have put it in the wrong place, but a few people, quite majority, got it right. Someone right on the edge, whoever that was, it's within the poles of the magnet. Okay, so you were super close. I don't know if it's in the rush to get it towards the pole, you missed it, but the area I've put is between the 2 poles of the magnet. Yes, I said either pole has the strongest. The lines are the closest together at those points, right? So the closer the lines are, the stronger the magnetic field. Unlucky for those of you that didn't get it. Let's see how that leaves the leaderboard. Quick Falcon still in the lead. Glorious Sugar Slider still trying to keep up. You're on the edge, Sammy. Oh, that's so annoying. Yeah, I just put it right at the pole, but I put the whole area there, and you were just outside of it, just outside of the pole. That's so unlucky. Can you do a live on the Force and Newtons or roll up bar? Yeah, to be honest, I'm thinking of doing that next, but obviously it's going to be more it's just making a quiz for it. So I will look to be doing that in the near future, maybe next week even. Yeah, so keep your eyes peeled. I will look to do that. So the leaderboard is still a chance for the top 3. Power Heron, TDK, you're a little bit behind, but you're on the leaderboard and you could get that second spot. First, maybe a bit difficult, but you never know. If Quick Falcon or Glorious Sugar Glider get it wrong, you're in with a chance. So keep going. Cool. Next question. Question 7. What is the shape of the magnetic field around a straight current carrying wire? Is it a spiral helix? Is it straight lines? Is it concentric circles? Or is it random arcs? You've just joined Vanilla Essence. That's fine. Obviously, it's just to learn. So jump into the quiz. I've left the code here 4918708. If you want to do it, join. You can still join. You'll just be in for the last 5 questions 4918708. No problem. Oh, you have joined. Nice. Your magic bow. If I see you on the leaderboard, that is an epic comeback of all comebacks if I ever see it. Let me know what place you end. I just want to see how you end up. What is the shape of the magnetic field? It is concentric circles. Remember, I talked about the dropping a pebble in the water. Those circles that come up, I drew it here, didn't I, as well? Here, these concentric circles. Yeah, circles that keep going around something. Those are concentric circles. So I don't know who put spiral helix. That's DNA. Yeah, we're talking about that's a different subject altogether. Straight lines. Straight lines are within a solenoid, right? So that's something different. But here we said concentric circles. You don't know why you're too slow today? It's okay. As long as you're getting them right, because you are getting nearer to the leaderboard. If you do that, then you're doing something right, right? Ultimately, it's about getting the right answer. The fact that you may be slightly slower than the others, that's it's not the end of the world. Obviously, you maybe missing out on the prize, but obviously at least you know the topic. What is the easiest topic on the spec for physics? Let's look at the leaderboard while I answer that. So that would be maybe it's one of the earlier ones. A lot of people say energy, for the different types of energy transfers. Some people like forces of motion. It's mostly preference. So yeah, I guess usually one of those topics is what people say most of the time. But then in physics, people tend to say everything's hard. So I don't know. Yeah, but there you go. Raghav agrees. Energy 100%. Yeah, people tend to say that. Cool. So, it's close now. It's very close to the top. Only 23 points between first and second. Wonder Liger's entered back again. I saw you at question 1 near the top, and now you dropped off and you're back again. Magnificent Armadillo's risen as well. Nice. And 5 people have got an answer streak of 6. That's good to see. People are getting it right. People understand the topic. So that's good. You think radioactivity is easiest? Fair enough. Fair enough, Iman. I mean, people have their own opinions, but yeah, I don't mind radioactivity personally. Yeah, fair topic. But yeah, can be difficult. Cool. On to the next question. Question 8. Type your answer this time. Type and press submit. Make sure your spelling is correct. What is the name given to when a wire is turned into a coil? Answers dropping in now. Have you spelt it right? Some people may have typed so fast that they made a mistake. And if you did, that is unfortunate because there is only going to be one right outcome here. It's spelling. There's no more than one word for this. There is only one word. I've even mentioned it a few times in this quiz. So I probably have given the clue away, kept it in your mind, hopefully. And hopefully the 11 that have answered it so far have got it right. 3 seconds. Someone may have dropped it correctly in the chat. It is a solenoid. And how many people have got it right? Let's see. 11. Everyone that answered it got it right. That is great. Yeah, good to see. Something I've mentioned today, everyone's been listening to. People did ask the question in the chat as well. So definitely one that came up a lot. Nice to see that everyone got it right. And it's still close at the top. It's still close. I want to see how this ends. This is an interesting battle. Just less than 30 points, 29 points in it. That is close. But Hero Dove is in with a chance on second. You're not far off, 90 points. Yeah, remember, even with the top 2, Hero Dove, if one of them makes a mistake, you're in at the leaderboard. So, guys, don't give up. Keep going. 7 correct answers in a row for Magnificent Armadillo. Well done to you. And let's see, Magic Boa, I think it was. Vanilla Essence. Maybe you might creep up there. Who knows? Okay, question number 9. In the right-hand grip rule for a solenoid, the thumb indicates the current direction. True or false? Falcon, please make a mistake. Raghav praying for the downfall of the others. Keep in with a chance still. Don't give up. You never know. Like you said, they could make a mistake. Let's see. Wrote that down because he said it was coming up. I did. Oh, did I say that? I said it may come up. But then I gave it away, I guess. Mixed answers here, guys. Mixed answers here. The answer is false. Okay. Remember, I mentioned for a straight wire, thumb indicates the current. But for a solenoid, thumb indicates the magnetic field. Remember, I put my hand horizontally there. So the thumb indicates magnetic field in a solenoid, and the grip indicates the current. For the straight wire, the thumb indicates the current, and the field is indicated by the grip. Philip made a mistake. I've caught people out with this one. Unlucky on that. Really split people here, but it was a bit of a trick question. Obviously, you won't get fully tricked in an exam or look to be tricked in an exam like that. I just wanted you to remember the difference. Yeah, so a solenoid, thumb is the magnetic field. In a straight wire, thumb is the current. That's the way you need to remember it. Prayers worked. Did they? Was Philip the top man? If Falcon is Philip, you think so? Let's see. Falcon is Philip, maybe then. Falcon has dropped, but still on the leaderboard. Yeah, so there's hope for everyone here. Magnificent Armadillo, that's you, Raghav, I believe. On your answer street, 8 correct. Really good. Devonshire, you clocked it. This is another game within a game we've got here. Guess who Philip is every week. I love it. Hero Dove in second. So there's still a battle between Hero Dove and Glorious Sugar Glider. About 70, 80 points. Not far. Again, just like Quick Falcon fell, someone else could fall. So those of you on the leaderboard, be keen, finger on the buzzer or typing, be on it. Yeah, you never know. You could be in with a chance of winning. The lead has changed once. It's the first time it's changed all game, which is interesting for once. Last time it changed quite a lot, I think, with a lot of mistakes. But let's see. Any more to come? Quiz question. Which material is best for the core of an electromagnet? Steel, nickel, cobalt, or iron? Answers dropped in well quickly there, hopefully because people remember. We did have a bit of a chat on it. And I explained specifically. People, I think I asked this question earlier and people were questioning it, but we kind of went through it a bit. So hopefully everyone picked the correct answer. Now, Sugar Glider is your turn. Raghav praying on each one's down for one by one. Everyone bar one got it. Iron. Yeah, we did discuss. People said, oh, why steel? It could be steel. Steel is not magnetically soft. Yeah, iron is magnetically soft. It can be magnetized and demagnetized easily, making it the best magnetic material. Okay. Steel, it can become magnetized, but won't become demagnetized very easily after that. Okay. So one thing to be careful of. How many questions are there? We've done 10. So just 2 more left, TDK. 2 more left. Let's see how the leaderboard looks and where you are on there, if you can make a comeback. It's still close to the top. Glorious Sugar Glider, 70 points ahead of Hero Dove and Magnificent Armadillo. Raghav still praying for that downfall, but still in with a chance with all 9 answers correct in a row now. So well done. Keep in with it. 2 more to go. Let's see what question 11 is asking us. A quiz question again. Multi-select though. Okay. How do you increase the force experienced by a wire in the motor effect? I did mention this, right? We said how to increase the force. We spoke about a couple of things here. We spoke about the equation to do with it, and we talked about looking at the diagram and how you can increase the force the wire would experience in the motor effect. Can you guys remember? 3 more seconds. Most people have answered. Well, I think everyone has answered. Let's have a look. Mix. Most people put the right one, but a lot of people put increase the potential difference. I never mentioned potential difference at all in this topic. I don't think I ever mentioned the word potential difference at all today. So I'm a bit disappointed people have put that, but it's unlucky. Yeah, it's in current that increases. Yeah, you increase the current in the wire, then that increases the strength of the magnetic field around the wire. And then we said more interaction between the magnetic field, so it increases the force. And then the second point, increase the flux density. Yeah, the magnetic field strength, in other words, stronger magnet, for example. Okay. How does that leave the leaderboard? Did one of the top people make a mistake? No. Everyone at the top 5 all got it right. And 4 people just hit an answer streak of 10. So got everything right. Fantastic. Good to see. A hard topic, but people understand the essence of it. So nice. Good. Quick Falcon, you're still on the leaderboard, but it may be too late to make a comeback, but good to see you still getting the answers right and staying on that leaderboard. Who is going to knock off Glorious Sugar Glider, or are they going to stay there for good? 2 more. Last question now. Type the answer. A 0.2 meter wire is put in the magnetic field of 0.35 Tesla. If there is a current of 0.1 amps, calculate the force on the wire in newtons. This is a calculation question. Remember, I saw the equation. The first answers have just dropped. Who is going to get this right? Who is going to get this right? So TDK has put, how many more questions? There's one left. Yeah, this is the last one. Correct. Who is going to get this right? So only 5, 6 answers dropped. A few seconds left. A few of you haven't answered yet. Can you remember? We went through the equation. It was just at the end there. I covered it. I say remember. I've left it on the screen here. I've just left it on there, I realize. 0.007 because it's F equals Bill. So everything is in its standard units. Length in meters. Tesla in is a standard unit for magnetic flux density, and current in 0.1 amp is 0.1 amps, which is a standard unit. So you just multiply all the numbers together. You had to go get your calculator, Raghav. I'm sorry. I should have said, to be fair, that is an error on my part. That is my bad. Let me review the answers. Who said that? That is right. Who even said that? I don't know. 0.67 someone put. I don't know where that came from, but maybe someone was thinking 6.7. I don't know. But unlucky. Let's see. How did that leave the leaderboard? Third place, 10,000. So 3 people got over 10,000 at least. Wonder Liger in third. Second place, Hero Dove, which means our winner, Glorious Sugar Glider. It didn't happen. I believe it's Glorious Sugar Glider because it would have been Hero Dove otherwise. Yes, it is. Just about by about 70 points. It was very close. Quick Falcon and Magnificent Armadillo, honorable mentions. You still got on the top 5 there, Raghav. That was you, Magnificent Armadillo, I think. You didn't cost your position. So getting a calculator or not, you still managed to get it in there. So well done. Well done, everyone. Dennis, let's go. Which one are you? Let me know who you are. Well done, guys, to our winners. Remember, as we've said, if you want to claim your prize, send us a screenshot, one screenshot of you in the chat with me today during the class, and one with your screenshot of your character on the podium. Okay. Dennis, it was you in first. No way. Again. Nice. Well done. Well done. Good to see you up there. Good win. Well done. Consistent. Very consistent. Good to see. Well done. And that is FRL classes member, people. So you can see the benefit. Maybe Dennis is also smart as it is anyway, but well done. Well done. Good to see you up there. Thank you, guys. Thanks for taking part. Thanks, Sammy. And that I'll probably leave it there for today. I'll stay on for another minute if anyone has any questions. Otherwise, have a lovely evening. Enjoy the rest of your Sunday evening. Those of you that may have exams, I know it's exam season for people in terms of mock exams and final exams, end of term tests before you get into your actual GCSEs, guys. So good luck for those if you have them. If this is a new method, I should not reveal my identity to anyone until the end of the game. Yeah, Devonshire, you see people are playing the game, but you're playing the other game. You're playing detective mode, but maybe you don't reveal it. It's up to you. It's up to you. It's nice to see a couple of people because then I can interact with them in the chat. You never know. Some people, they've said it and they've won. So, it's not a tactic that helps you win or lose, but yeah, you don't want people like Rugger playing for your downfall either. You never know. For the generator effect, I don't understand the difference between alternators and dynamos. So that's a triple topic. We will be getting into that, Raghav, in our FRL classes. So if you want to join us for that, please do. But just off the top, the difference is that with a dynamo, you're applying the force yourself, right? Dynamo example is always like someone riding a bike, and then they're using the motion they're getting from the bike is the rotation you need to create the induction of the current in the wire. Yeah, so it's motion to create a current in a different way. Yeah, so you're doing that with a force. An alternator, the diagram is slightly different. It looks like the diagram for a generator, but you don't have the battery in it. Now, with a generator, you have a power supply connected to the split ring, but in an alternator, you don't have the power supply. You have a circuit on that end, and the motor is spinning from another method. Yeah, so an alternator, a dynamo can almost be an example of an alternator in a way. Yeah, because that's the dynamo is this initial effect that brings that rotation motion into the alternator in a way. Yeah, so they're kind of interlinked, Raghav, in a way. But I'm going to go into more detail with those diagrams and stuff in our classes. So if you're interested, you want to have a look a bit more of this, stay tuned or join us on our FRL classes. We'd love to have you there. But thank you very much, guys. Any other last questions before I head off? If not, thank you very, very much. Good to see you guys and have a good rest of your evening. Take care.